In this demonstration, we will explore some of the most important log files in Red Hat Enterprise Linux, including /var, /log, /messages, /var, /log, /secure, /var, /log, /cron, and dmessage. These logs help administrators monitor security, troubleshoot issues, and understand system behavior. To begin, click on the Activities tab located in the top left corner of your screen. Next, locate the terminal icon at the bottom of the Activities view and click on it to launch the terminal. First, let's navigate to the log directory. In the terminal, type cd/var/log, then press Enter. This command takes you into the log directory, where system logs are stored. Now, list the files with detailed information. Type the following command: ls-lh. Here, in this command, ls lists the directory contents. -lh lists files in a long, human-readable format. Then press Enter. In the output, you'll see various log files such as bootlog, firewall-d, vbox logs, mail log, last log, and many others. These files help monitor and troubleshoot nearly every aspect of the system. Clear the terminal for a fresh view. Now let's view /var/log/messages, which contains general system activity logs. In the terminal, type /var/log/messages. In this command, ls opens the file in a scrollable viewer, and /var/log/messages is the file containing general system logs. Then press Enter. You'll now see logs related to system activity, services, and kernel messages. To quit, press Q. Next, let's use the tail command to view the latest logs. Type the following command: tail-f/var/log/messages. In this command, tail displays the last 10 lines of the file, showing the most recent logs. -f stands for follow and keeps the terminal updated live as new log entries are added. Then press Enter. You'll see the most recent system activity at the bottom of the log. To quit, press Ctrl+C. Let's clear the terminal for a fresh view. To view /var/log/secure, which stores logs related to authentication and sudo attempts, type the following command: tail-f/var/log/secure. Here, -f keeps the output live as new log entries are written. Then press Enter. You will see real-time logs related to login attempts, sudo usage, SSH authentications. To stop the live log view, press Ctrl+C. Clear the terminal screen again. To view the scheduled cron jobs and their execution logs, type the following command: tail/var/log/cron. Then press Enter. In the output, you will see logs showing when cron jobs were executed, the time of execution, which user triggered the job, and what script or command was run. Now clear the terminal screen for a fresh view. To view the boot time hardware messages, type the following command: sudo dmesg, insert a pipe operator, then type less. Here, in this command, sudo runs the command with administrative privileges. dmesg displays system and kernel messages, especially those related to hardware and boot processes. Pipe operator less allows you to scroll through the output one screen at a time. Then press Enter. In the output, you'll see boot time hardware messages, kernel events, file system checks or FSC tables, device initialization, and more. To quit the viewer, press Q. And that concludes our demonstration on exploring some of the most important log files in Red Hat Enterprise Linux. In this demonstration, we will access and filter logs using the Journalctl command, the systemd-based journal logging utility in Red Hat Enterprise Linux. We'll explore how to filter logs by time, priority, system units, and boot sessions. To begin, click on the Activities tab located in the top left corner of your screen. Next, locate the terminal icon at the bottom of the Activities view and click on it to launch the terminal. First, let's view the basic system journal logs. In the terminal, type the following command: Journalctl, then press Enter. In the output, you can see the full journal log, which includes all system logs collected by systemd. Use the arrow keys to scroll through the logs. To quit, press Ctrl-C. Now clear the terminal for a fresh view. To filter logs by time, we use the -- since option. In the terminal, type the following command: journalctl -- since, inside double quotes type, 2 minutes ago. Then press Enter. This will display only the logs generated in the last 2 minutes. To exit the log view, press Ctrl-C. Clear the terminal for a fresh view. Now, let's check system logs between 2 specific dates. In the terminal, type the following command: journalctl -- since, open double quotes, and type 2025-07-25, close double quotes, then type -- until open double quotes again and type 2025-07-26, close double quotes. Then press Enter. The command displays system logs recorded between July 25th and July 26th, 2025. Once the logs are displayed, press Ctrl-C to quit. Then, clear the terminal screen. Now let's filter journalctl logs by a specific service or unit. In the terminal, type the following command: journalctl -u sshd. Here, in this command, -u stands for unit. SSHD is the name of the service we're filtering logs for. Then, press Enter. The output will show all logs related to the SSH service. Once you're done viewing, clear the terminal to start fresh. Now let's filter logs by priority using journalctl. In the terminal, type the following command: journalctl -p small err. Here, -p stands for priority. ERR filters for error level messages and above. Then press Enter. The output shows critical messages, such as kernel errors, systemd failures, or any other high-priority system issues. Once you've reviewed the logs, press Ctrl-C to exit and clear the terminal for a fresh screen. Now let's filter logs based on boot sessions using journalctl. First, to list all available boot sessions, type journalctl -list -boots. Then, press Enter. This command shows a list of recent boots along with their IDs and timestamps. To view logs from the previous boot, type journalctl -b -1. Here, -b stands for boot. -1 means one boot before the current. Then, press Enter. In the output, you can see no logs appear because there's no previous boot record available. To check logs from the current boot session, press up arrow key and bring back the previous command. Change -1 to 0. Then, press Enter. This shows logs from the system's current boot. Once done, press Ctrl-C to exit the view and clear the terminal for a fresh screen. Now let's view real-time streaming of logs using journalctl. In the terminal, type the following command: journalctl -f. Here, -f stands for follow, which shows new log entries as they appear. Then, press Enter. You'll now see logs updating in real time as system events occur. This is especially useful when you're troubleshooting and want to monitor live activity. To stop the stream, press Ctrl-C. Then, clear the terminal to start with a clean screen. Let's now view high-priority logs from the last boot, specifically related to a service. In the terminal, type the following command: journalctl -b -p small err -u sshd. In this command, -b shows logs from the current boot. -p err filters logs to only show entries marked as errors. -u sshd narrows it down to the sshd service. Then, press Enter. If there are any error level logs related to the SSH service since the last boot, they'll appear in the output. In our case, since no errors have occurred, you can see no entries in the output. And that concludes our demonstration on accessing and filtering logs using the journalctl command in Red Hat Enterprise Linux. In this demonstration, We'll explore how log files are rotated and managed in Red Hat Enterprise Linux using the logrotate command. Log rotation helps prevent your disk from filling up and keeps logs well organized and easier to manage. To get started, open the terminal. Click on the Activities tab at the top left corner of your screen. Then, click the terminal icon at the bottom of the Activities view to launch it. First, let's check the logrotate configuration file. In the terminal, type the following command: cat/etc/logrotate.conf. Then press Enter. This command displays the main configuration file for logrotate. You'll see that logs are rotated on a weekly basis. The configuration also specifies that 4 weeks of log backups are retained. Additionally, you'll notice that individual packages often drop their own log rotation configurations into the directory /etc/logrotate.d. That's where you'll find service-specific settings. Now let's check what's inside the /etc/logrotate.d directory. Clear the terminal for a cleaner view. Then, type the following command: ls/etc/logrotate.d/. Press Enter. In the output, you'll see a list of system services that have their own log rotation settings. These may include services like HTTPD, FirewallD, DNF, cron, rsyslog, SSSD, and many others. Clear the terminal again to proceed. To perform a manual log rotation, type logrotate-f/etc/logrotate.conf. Here, -f option stand for force, which rotates logs immediately, regardless of their scheduled time. Press Enter. This will trigger the log rotation process based on the current configuration. Next, let's verify the rotated logs. Type the command ls-lh/var/log/secure insert **. Here in this command, ls lists the files. -lh displays human-readable file sizes with detailed information. In /var/log/secure, * includes the current and any rotated versions of the secure log. Press Enter. In the output, you should now see only the most recent log file. For example, logs from July 25th, while older ones have been rotated or cleared, depending on the configuration. Clear the terminal screen again. Now, let's define a custom log rotation rule. In the terminal, type nano/etc/logrotate.d/custom log. Press Enter. This command opens a new file in the Nano editor to define our custom log rotation. Inside the file, type the following configuration: /var/log/custom.log, then open curly brace. In the next line, press Tab and type weekly. Press Enter. Then, press Tab again and type rotate for. Press Enter. Press Tab and type compress. Press Enter. In the next line, press Tab and type missing OK with no space. Press Enter. Then, press Tab and type not if empty. Press Enter. And finally, close the curly brace. Here's what each line means. /var/log/custom.log is the log file we want to rotate. Weekly means the log file will be rotated every week. Rotate for keeps 4 old versions of the log before deleting the oldest one. The compress option instructs the system to compress old log files in order to save space. Missing OK skips rotation if the log file doesn't exist. Not if empty means the log will only be rotated if it is not empty. To save and exit, press Ctrl+X, then Y, and press Enter. The custom log rotation policy is now saved. Let's test the configuration by first creating the custom log file. Type the following command: touch /var/log/custom.log. Then press Enter. This command creates an empty log file named custom.log in the /var/log directory, the same file our custom rotation is configured for. Next, let's manually trigger the log rotation. Type the following command: logrotate-f/etc/logrotate.d/custom log. Then press Enter. This command forcefully runs the log rotation using our custom configuration file. And that concludes our demonstration on exploring how log files are rotated and managed in Red Hat Enterprise Linux using the Logrotate command. In this demonstration, we'll make systemd journal logs persistent even after system reboots. By default, these logs are volatile, meaning they're lost when the system restarts. Making them persistent is crucial for long-term auditing and effective system troubleshooting. To get started, open the terminal. Click on the Activities tab at the top left corner of your screen. Then, click the terminal icon at the bottom of the Activities view to launch it. Now let's check how much disk space the journal logs are currently using. Type the following command: sudo journalctl --disk--usage. This command shows how much disk space is currently being used by system journal logs. Then press enter. You'll see an output like archived and active journals take up 8 MB in the file system. Since the system has just started, the usage is small. As the system runs longer and generates more logs, this number will increase. Let's see where these logs are currently being stored. Type ls-small-ld/run/log/journal. In this command, ls lists directory information. -ld shows details about the directory itself. /run/log/journal is where temporary journal logs are stored. Then press enter. In the output, you'll see that systemd journal logs are written in this temporary location. These logs are stored in memory and will be lost after a reboot unless persistent storage is configured. Clear the screen for a clean workspace. Now let's set up a directory for persistent logs. This ensures that your system logs are saved even after a reboot. Type the following command in the terminal: mkdir-var/log/journal. Here, mkdir creates the directory. -p ensures any missing parent directories are created. /var/log/journal is the path systemd uses for persistent logs. Then press enter. Next, we need to prepare the new directory so that systemd can use it. Type sudo systemd-tmp files -create -prefix /var/log/journal. Then press enter. This command sets up necessary files for systemd to write persistent logs. Now restart the journal service to apply the changes. Type systemctl restart systemd-journald. Then press enter. The system journal service is now restarted and persistent logging is enabled. Let's check the journal log usage again. In the terminal, type journalctl -disk-usage. Then press enter. The output should still show something like archived and active journals take up 8 MB in the file system. Finally, let's confirm that the persistent log directory is active. Type ls/var/log/journal/. Then press enter. If this directory is empty, it means the journal log hasn't been created yet. To activate persistent logging, you'll need to restart your system. And that concludes our demonstration on making systemd journal logs persistent even after system reboots. In this demonstration, we'll explore how to analyze system logs to detect issues like suspicious activity, failures, or performance bottlenecks. To begin, click on the Activities tab located in the top left corner of your screen. Then, click the terminal icon at the bottom of the view to launch it. Let's start by scanning the system logs for error messages. In the terminal, type grep-i error/var/log/messages. Here, grep searches for matching text. -i tells grep to ignore case while searching. Error is the pattern being searched for, which will match any occurrence of the word error in any letter case. /var/log/messages is the main system log file we're scanning. Then press enter. In the output, you'll see all log entries containing the word error. For example, in this case, on July 28th, you can notice an error message linked to the kernel or user, John. indicating a misconfiguration. Clear the terminal screen before proceeding. Next, let's check for failed services or authentication attempts. Type grep-i fail/var/log/secure. Then press Enter. In the output, you would normally see entries for any failed services or authentication attempts. In our case, there's no result. That means no recent failed service or login attempts were logged. Clear the terminal again for a clean view. Now we'll check for executions of the past wd command using audit logs. Type sudo au search-x past wd. Here, sudo gives us the necessary permissions. Au search is used to search through audit logs. -x past wd filters the results to show all executions of the past wd command. Press Enter. In the output, you can see a history of all attempts to run the past wd command. For example, it might show usage on July 24th, July 23rd, and even earlier on July 11th or 14th. This helps track password changes or attempts to modify user credentials. Clear the terminal before the next step. To check password login attempts by the current user, type the following command. Au search-u insert $, inside parenthesis type. Who am I? Here, in this command, -u searches by user audit ID. $, and who am I inside parentheses dynamically fetches the current logged-in user's name. Then press Enter. This command displays all password-related login attempts made by the current user. Clear the terminal screen again. Next, let's check the login history using the last command. In the terminal, type last, then press Enter. In the output, you'll see a list of recent user login sessions. For example, the root user may appear as logged in on TTY2 and also on seat 0, which is the graphical login screen. You may also notice that the system is currently rebooted and running. To view failed login attempts, type last-b, then press Enter. This command checks the log of bad login attempts. If there have been no failed attempts, you'll see only timestamps or an empty result. Clear the terminal screen to continue. Let's now check for kernel-related errors, such as disk or hardware issues. Type Journalctl-k, insert pipe operator, then type grep-i error. Here, in this command, -k filters messages from the kernel. The pipe passes that output to the next command. grep-i error searches for lines containing the word error, ignoring case. Press Enter. In the output, you'll see all kernel messages that include errors, such as disk-related issues or hardware faults. Clear the terminal for a fresh view. To identify performance bottlenecks, we use the top and the top commands. In the terminal, type top, then press Enter. This command shows a live view of system activity, including running processes, CPU, and memory usage. For example, you may notice GNOME shell is active because we're currently using a graphical environment, and systemd is also running as part of the system management. Press Ctrl-C to quit, then clear the terminal. So with the right tools, system logs can help you uncover hidden performance issues or even signs of break-in attempts. And that concludes our demonstration on how to analyze system logs for suspicious activity, failures, and performance bottlenecks. In this demonstration, we will configure Red Hat Enterprise Linux to forward logs to a remote log server using rsyslog. In large-scale environments, centralized logging is essential for monitoring, auditing, and troubleshooting across multiple systems. To begin, click on the Activities tab located in the top left corner of your screen. Next, locate the terminal icon at the bottom of the Activities view and click on it to launch the terminal. Let's start by enabling the rsyslog service. In the terminal, type the following command: systemctl enable --now rsyslog. Here, in this command, systemctl is used to control system services. Enable makes sure the service starts on every boot. --now starts the service immediately. Then press Enter. This command ensures that the rsyslog service is both enabled and running. Next, we'll configure rsyslog to forward logs to a remote server. Let's open the rsyslog configuration file. In the terminal, type the following command: nano/etc/rsyslog.conf. Then press enter. This command opens the rsyslog configuration file in the Nano text editor. Use the down arrow key to scroll to the bottom of the file. At the bottom, type the following line: *at 192.168.0.100:514. Here, ** means all log messages from all facilities and priorities. At 192.168.0.100:514 specifies the remote log server's IP and port. Once done, press Ctrl X to exit. Then press Y to confirm, saving the changes. Press Enter to save the file with the same name. Now that the configuration is updated, restart the rsyslog service. Type systemctl restart rsyslog. Then press Enter. This command restarts the rsyslog service and applies the changes. Next, we need to allow UDP port 514 through the firewall so log messages can be sent out. Type the following command: firewall-cmd-add-port equals 514/UDP-permanent. Then press Enter. In the output, you'll see success. This confirms the port was added to the firewall rules permanently. Clear the terminal screen before continuing. Let's reload the firewall to apply the new rules. Type the following command: firewall-cmd-reload. Then press Enter. Again, you will see success. This confirms that the firewall has reloaded with the new settings. With this setup, your RHEL system will now forward logs to a remote server using rsyslog. So central log collection enhances visibility, security monitoring, and regulatory compliance across large environments. And that concludes our demonstration on configuring Red Hat Enterprise Linux to forward logs to a remote log server using rsyslog or Journalctl.